Hey guys, welcome to our last video demonstration like this. In this one, we're going to talk about how to go from a graph of a polynomial to a function, to the equation of it. Okay, and the way those questions are typically worded are going to be find the equation in lowest terms or in least degree. And so what that's talking about is, if we look at this, what degree is it? Now, you may jump in and say something, but what we know, because these two go straight through, we know they're both 1. And because both ends go up in the same direction, we know this has to be even. Now, we're probably going to jump and say, oh, well, this must be 2. But why is it 2? Could it be 4? Because 4 bounces. So does 400. So we don't know what this multiplicity is. All we know is it's an even one. And that's why we say lowest terms or least degree. And what that's simply referring to is if something bounces, we say 2. If something flattens, we say 3. If something goes straight through, we say 1. And that's it. Okay? So the way to start this out is really easy, okay? We need to identify our roots and kind of their lowest multiplicities, and then we can just write that into our function. So I know that this function, it's going to be in factored form. So I'm going to have my leading coefficient, which I don't know what that is. So I'm just going to leave it as a. We'll say a sub n, okay? Now I can list off all my factors. Now, do I need to have an x here by itself? I want to kind of keep somewhat. If I had an x here by itself, that would mean I had a root at 0. But I clearly don't have a root at 0, so I'm not going to have a sub n times x anything. So I can start listing my factors. Now, my first factor is here at negative 3. So what that means, if x equals negative 3 makes my function equal 0, because my factor is x plus 3. Think about this, right? Because if x is negative 3, then this is 0. So that would give me that root at negative 0, at negative 3. Now, what exponent do I put on here, or do I put 1? Well, since this bounces off, and we're talking about least degree, we need to have this as an exponent of 2. Okay? And we continue this process on for our next two. Now, I'm going to do something simultaneously. Both of these go straight through. So both of these have a multiplicity of 1. So when I'm writing the factors, I don't need to put an exponent on them. Nice and easy for me. Now this one here goes through at 2. So that means if x is 2, this term has to be 0. So for that to be true, this would need to be minus 2. And lastly, this one here is at 4, so we need to have x minus 4. Okay? So what I've done so far is simply used the roots and their multiplicities based on using the idea of least degree, or lowest terms. And I've gotten all of my factors filled in. The only thing left to solve is this one unknown. Now, if you remember back from anything we've done before, when we get an equation down to where we have one unknown, we almost always use another point and plug that into our equation. And that's the exact same thing we're going to do here. We're going to use the fact that this goes through the point and has a y-intercept at 18. Which means it goes to the point 0, 18. Make sure you can see that. Yeah, you can see that. All right, good. Standing from this far away, a lot of this is blurry on my screen. So, what that means is if x is 0, this function equals 18. So I get the equation. 18 equals a sub n times 0 plus 3 squared times 0 minus 2 times 0 minus 4. This, everything is known except for a sub n, so that means I can solve for a sub n. It's easy. Well, relatively easy, we'll say that. So, I'm going to kind of combine some things because I don't want to get too low. 0 plus 3 is 3, and 3 squared gives me 9. Okay? 0 times minus 2 is negative 2, and 0 minus 4 is negative 4. So I have negative 2 and negative 4. Multiply those together, and I get a positive 8. Okay? So, 18, a sub n. Now, if we multiply 9 and 8, we get 72. Okay? Now I have 18 times a sub n times 72, divide. So we divide by 72 on both sides. Now, I don't know about you guys, but 18 divided by 72 isn't necessarily in my wheelhouse. So, if I do 18 divided by 72, I get 0.25. Now, I want to keep this as a fraction because decimals are messy. So, for those of you that have forgotten, this little button here says math. First option, fraction, so we're just going to hit enter. We're going to hit enter. Okay. Now it says this. So what this is telling our calculator to do is it's saying take the last answer, this 0.25, and turn it into a fraction. And I get 1/4. So that means a sub n is 1/4. So I can go back here, and typically the way I do this, I rewrite this all. So that's what we're going to do. So instead of a sub n, I know it's 1/4. And that's my answer. So going from a graph to a function, to an equation, is pretty easy if you can just remember how to turn the roots and multiplicities back from the graph form to the equation form. Once you do that, you just have to know one other point which you plug in and solve an equation. It may look crazy and terrifying, but it's really just a simple matter. Use your calculator, take your time, do those calculations carefully. And that's it, guys. That's polynomials. So you guys have everything you need. Get to work, crush this section. There's going to be one other video using Desmos just to kind of exemplify those kind of multiplicity behaviors. I'm just going to kind of zoom in and use that. It's going to be really quick and easy. Don't feel like you have to watch it if you're comfortable with the idea of multiplicity in their behaviors. If you want to see a visualization of it, watch that. All right, guys. See you later this week.